All right, let's get started. Um, Hi, everyone. Thanks for attending this lightning talk. Um, I'm going to talk about why blockchain doesn't make sense. You've probably heard it a million times, 1,000 times, how blockchain could eventually change the world. It's the next big thing. It's the future. But, someone who actually did try blockchain hands-on professionally, there are a lot of things that I learned for the past 2 3 years doing blockchain. Um, it's tough. I think that's something you need to understand because blockchain is not just about technology. Most of the time, I figured the hardest part of implementing blockchain is the um, people readiness or a collective understanding what blockchain is. And that's the real challenge of implementing blockchain. So let's start with why it doesn't make sense. Because first and foremost, you probably don't have partners. The whole premise of blockchain is for it to be decentralized, distributed. But if your platform is centralized in terms of governance, means you own all the VMs, all the nodes, then it doesn't really make sense. On the other hand, if a certain business unit, say your IT department or your ops department, is the one managing and owning the whole responsibility of the infrastructure, that also doesn't make sense. Because the whole premise is that it's decentralized. No one virtually, logically, or physically owns those data. And lastly, as part of consortium or implementing blockchain, whether it's public or semi-private, if there's no trust issue that you really want to solve, like if the inter system communications just work, and you just want to implement blockchain, it doesn't make sense because the whole premise of blockchain is that there is a trust issue that you want to solve, meaning you want partnership, but at the same time, you want to ensure that the partnership is strong through a decentralized system, and that's where blockchain really fits in. Next part of the puzzle is that it is hard to scale. If you have heard before, transaction fees and the time it takes to transfer Bitcoins or Ether last December, it's too damn slow and it's too damn expensive. And that's because it was written that way. It's hard to scale. Then there are those different setup where it's semi-private, meaning say different organizations actually owning those infrastructure, not just centralized to one business unit. But still, it is expensive. Another part of that cost is that it's expensive in a way that versioning of smart contracts is painful. So think about it. The whole premise of smart contracts or programmable logic is that once you deploy it in the blockchain, there's no turning back. It gets an ABI, meaning a bytecode identifier. That bytecode identifier can be called by anything. There's no way to destroy it. It's there forever. So in order to, say, update your smart contract, the only way to do it is to create a new smart contract and ensure that your end systems or your integration is matching on the new ABI. But no one is stopping anyone to still tap on the previous ABI. So that's a known problem in a blockchain network. The whole premise of it being immutable comes with a price and the cost of scaling, which is a permanent smart contract. So that's something you also need to understand why it doesn't make sense sometimes. And that also goes into the picture of if you plan to implement a CI/CD, then you're also going to jump into the same problem. So, and I would also like to mention further challenges of blockchain is that, like what really touched me before when I started learning blockchain is that there's the promise of making a decentralized voting system, that we don't actually need a centralized voting system in order to achieve leadership and governance. However, as I dig deeper into that space, yes, that's right. You can actually append data, meaning a certain address can actually vote for a certain person or a certain, idea. But the problem there is that in the blockchain, there's only a key value pair of private key and public key. And the real problem there is that there is still no way to really determine that this private key or this public key is that person, meaning you're anonymous in the blockchain, which makes sense sometimes. And, but in the collective idea of a decentralized voting system, for me, it doesn't make sense because I can just orchestrate a lot of accounts and just do a lot of votes for as long as I have a lot of tokens. I can do a lot of votes, right? So, again, I think blockchain is at its infancy, and there are a lot of further development along the road, and I think this is the thing we need to solve for it to really mature. The knowing who am I. There are now a lot of different movement in this space. Ideally, talking about integration with AD, having integration with vaults, like key vaults and stuff. But still, I want to come to a point where it makes more sense to really justify that whoever is appending on a blockchain, which is an immutable ledger, is that it is that someone. Second part is that more and more people are diving into the blockchain space, but the problem there is that it's not yet regulated, not just the cryptocurrency or the utility tokens, but it's one of those things that it's not very straightforward to the users. So unlike, you say, mobile apps, AR, VR, it's very tangible for the users, what that means. But if you talk about blockchain and you talk to ordinary people, the general mass, it takes a lot of effort for them to understand what that is. And to a point that it gets too complex for them, and there's a very little value in the end. Probably a very good example is if you want to let them understand Bitcoin or the whole idea of transferring tokens. It takes a lot of effort for them to understand, or for everyone in this room to understand how the mechanism works. But eventually, what you're just after is that you just want to transfer a value, right? And I think, we need to come to a point where it's more of a cultural and social movement that this, decentralized fashion is something that's kind of normal. All right. Okay. Let me just quickly go back on the hard to scale aspect. There is an instance where a company would just like to, ride the blockchain hype, and at no matter cost, they just want to use blockchain. The problem there is that in terms of scaling, in order to implement blockchain, it's not cheap, and it comes with a cost. A cost roughly, we're talking about at least 8 VMs. So we need at least like 6 transaction nodes and 2 minor nodes. And realistically, if you're gonna, try to run a lot of transactions, you're looking fairly around 2 grand or 3 grand cloud computing costs per month. Question is, for those companies who really wants to dive into this space, is the cost justifiable enough for the value that you want to achieve? Because in some cases, it is very cheap to just run, batch processes across systems. Microsoft has done it before with BizTalk. So it's basically, a new, just a new way of doing things. But the whole point there is that it comes with cost. And, it doesn't make sense sometimes because the cost is too much for the value that it brings. But maybe if you're talking about, high-valued transactions, maybe it does make sense. So again, those are some of the considerations that you really need to know. All right. And again, I just want to end this talk by saying that, probably, in 10 use cases I've had for blockchain, it's only one of them really made sense, and 9 of them just wants to, ride on. So I'm gonna be here until Friday, until tomorrow. So if anyone wants to know more about blockchain or wants to prove or disprove if your idea is makes sense to do it on blockchain or not, happy to do it. We have 4 minutes for any question. Mm-hmm.
But at the same time, you can't verify that those participants are who they are.
Exactly. Yep. That's why it's 1 out of 10 chance that the use case is a good blockchain use case. For me personally, the only good use case I find right now is supply chain. Supply chain because first is that there are different parties involved. Meaning, if you want to decentralize it, different parties can participate by setting up their nodes, their VMs, and ensuring they participate. No centralized party actually, owns the majority of the nodes. Second part is that they do, they do trust each other because they're partners in the first place. But they want a system that works for them, transparent enough to ensure that they have data integrity across different part of the supply chain. And lastly is that you don't actually need to track who they are, what their transaction details are. You just need to ensure that the transactions are shared across different business units. What that means is that you have a smart contract that can be consumed by those different parties. The way they want to integrate it to their systems, that's totally up to them. But the point there is that they have a decentralized ledger that's transparent across them. So what that means eventually for identity is that probably they want to match it to drivers from the AD of that supply chain company, and it actually matches as well with the actual parcel that they want to transfer. Two more minutes. Any question more? Yep.
So it doesn't solve the who am I problem.
Mm-hmm.
The whole blockchain can be used for something like identity proof, but
Mm-hmm.
not exactly the blockchain itself.
Yep.
Something like Civic, for example,
Mm-hmm.
trying to do that. So different participants, some participants validate people's identity, some participants just normal clients, they just want to put their identity there as a proof of their identity.
Mm-hmm.
So still blockchain can be used to make that trustless economy happen so that they all work together, but doesn't solve itself.
Yeah. I think as a closing remark is that if you're treating blockchain like a database, it's not a silver bullet. That it's basically a garbage in, garbage out scenario. If you're putting a garbage data inside the blockchain, it's still a garbage data when you actually pull it out. So it's just a mechanism to make it distributed, transparent, and decentralized. But it doesn't automatically, make sure that this is the magic data that you're looking for. All right then. Thank you very much.
Okay, hello everyone. My name is Ozzy. I'm Alexa Developer Evangelist, and thanks for joining me today. My goal in the next 10 to 15 minutes is just to make you familiar with Voice Platform. We keep talking about it, that it's the next big thing, and I just want to make sure everyone knows why it got big at this point, and if you are considering to go through this direction, what are the things that you need to think about. So every decade, we embrace a new way to interact with technology, from character mode to graphical user interface to web and mobile. And each one of these platforms brought a magical moment when we realized what we suddenly could do. Just remember the first time that you used a mouse to click on something, or you use your finger to pinch and zoom in and zoom out. The experience was magical at that point, but we soon got used to it. In the same way, we think we are at the point that the voice user interfaces are bringing that magical moment and allowing us to do things that we wouldn't do normally. So my journey with voice started many years ago when I started implementing an application for an IVR system. So if you've played with these systems, they allow them to interact with technology using a telephone. And at the point, the interaction and testing these systems was pretty amazing. I still can remember good memories from them. But when you interact with these systems, you are probably familiar with the experience of hitting zero and talking with a real human. And the reason is because the interaction wasn't seamless and it wasn't the natural form of conversation. So 2 years back when I got my Echo devices and I was starting to interact with that, I was thinking, are we at the point that we are capable to interact with machines naturally? And the answer was yes, thanks to all advancement in technology. Cloud computing had definitely been a catalyst in this space, along with improvement in natural language understanding and speech recognition. So to make a point, how many Star Trek fans we have in this room? That's cool. So this is a scene from Star Trek 4 from 1986. And if you don't know Scotty, Scotty is the chief engineer and the tech guy. And this is his first interaction using a computer.
Computer.
We don't have voice.
Computer.
If it doesn't resolve, I can read through what he's trying to say, but let's give it a try. Is there anything I should do? Yeah.
Computer.
Okay. So let me read that through. So he's trying to grab the mouse
Hello,
and
computer.
start interacting with it, and they're all
Just use the
surprised
keyboard.
in a sense. And when in the last scene, when the guy asked him to use a keyboard, he's saying, "A keyboard, how quaint!" And of course it is, because that's not the natural form of interacting with something. But the technology at that point was there, and we were not able to interact with voices. We were trying to adapt to the technology, but now that we have voice, they can adapt to us. So we talk about voice. It's a new platform, and I don't know if you guys remember, when we got mobile app, we tried to apply all of the design patterns of web pages and user interfaces to them, and it wasn't a good experience. Like we were trying to add so many text on the mobile, and the buttons were really small, so we were not able to click on them in a sense. So it took us a while to figure out the platform is different and we have to think differently. So what's different for voice? These are some of the topics that I want to go through. So first of all, eyes expect uniformity. When we talk about graphical user interfaces, we want things to look the same. And the reasoning is that because we want to have consistency, we want to give users the visual clue to be able to find things and just removing the cognitive loads for them. So if I ask you guys to go and create a mobile app, and each one of the page should look different, different font, different positioning and everything, that's a very, very bad experience. But for ears, it's totally different. And to show a point, you can imagine that if you show up at work and have a discussion with your colleague every day, asking them the same question and they come back with the same answer, you kind of lose your interest because the ears expect variety. So when you are creating experiences with voice, let's say you want to say goodbye at the end of the interaction, don't always use the same wording. You can just randomize it and just surprise and delight your customers in a sense. And visual user interfaces helps with imagination. I was playing with a game with a skill called Magic Door last night. And it's a game you start, a door opens and you start interacting. It just gives you options where you want to navigate. And it was pretty interesting because there was no user interfaces. I was imagining myself in whatever scene that I wanted my brain to think of. And that was pretty powerful. I like to compare it when people talk about reading the novel of Harry Potter and then watching the movie, and people think the experiences are totally different. That's because the ears allows you to imagine things instead of providing the visuals. And the last part is writing for voice is different than writing for UI. Like if you have a banking app and you want to have a voice type of interaction, you cannot just copy and paste the same messaging in the voice and just hoping that it works the same way. Like we just write very formally, but when we talk, it's more casual. We add emotions, we add all of these things, which is pretty unique to type of interactions. So some of the key design principles for Alexa skills, and it's for any other type of voice interactions. So adapt to how users naturally speak. So the power of voice is that it's the most natural form of interaction. It's not yet another user interface that people have to learn and adopt. Just be cautious of that, and when you are creating the interaction, it should be seamless and as natural as possible. And let's say if you're creating a skill for I don't know, high school students, that they have some jargons that has no meaning for us, but they use it every day. That means that's the norm for natural interaction, and we have to adapt to it. The second one would be you should provide an individualized type of interaction. In a normal conversation, we have the concept of context. If I talk to you about my trip and my likes and dislikes, you kind of build an image around me, and next time you use it to fit into the coming interactions. So we should do the same in voice interactions, and there are very easy ways to persist information in databases. And you can just, when you grab information, their name, their likes, their dislike, just remember them and use it next time. One good sample for that is when they start interacting with a voice interaction, if this is their first time, and we can easily tell by checking the timestamp of last time they use it, we can provide more information, like to play with these skills, you can do this and that. But as they play with the skill and they learn how to do it, we can just make the conversation shorter and help them with other features. And the last one is think of availability, rethink menus and top-level UI. I talked about IVR system in the beginning. So we were trying to apply the same concept of having menus in user interfaces and saying, start with number 1, then go to 2 and 3, and just walk to a hierarchy. People don't talk that way, and they easily can forget what number or which path to go. The interaction should be seamless and very natural. And the way to do it is to have just all of the features to be high level. Like I should be able to ask for every individual activity I want to do in one shot, and this skill should figure out what I'm thinking about. So if you want just to grab something from this presentation, just remember to choose voice when it is easier, faster, and more natural. Voice is pretty cool. You don't have to convert any type of application to voice. You need to make sure that it's convenient and easier to use. Like before using Alexa devices, I never thought I would say setting up alarm in a mobile phone is a hard task, but now that I have Echo devices at home, it's really hard for me to go back and just locate my mobile and unlock it and set a timer. It's pretty easy, but when I do it with voice, it's much seamless and easier, and that's why people use it. So if you got interested into voice interfaces, I'll have a workshop later today at 3 o'clock, and I'll walk you through how Alexa works and how interaction goes through the servers and come back, and how easy it is to create an interaction using the Alexa platform. And I had a video to share, so unfortunately we don't have voice, so I'm pretty much done, and if you have questions, I can grab one question at the moment. Any question about voice or Alexa? Yep.
Do we have a good solution to that context problem, or is this something that we have to invent ourselves?
No, so some of the platforms like Alexa, so we have some SDKs that allows you to easily persist information either within the length of the conversation when they start an interaction till they finish the interaction. So we call it, in a sense, session attributes, like it's persisted throughout the session that you are having with the person. But it's always good to go one step further and just persist it in like DynamoDB and everything. And the platform is there, the solutions are there, and there are so many libraries that can help you there. To be honest, for voice, the technology is not a problem anymore. Like we have everything there, the design and how you can think of making that interaction seamless is the point that you need to think about and do it properly. Yeah. Any more questions? Yep.
Say you want to make Alexa a skill for a banking context.
Yep.
How would you tackle ensuring that the user who's asking the question is authenticated and making sure that you only give so much data to them?
Yeah, so that's a very good question, because at the moment we have these devices at home, so when you say your password, everyone can hear it in a room, so that's a problem. So we have one concept called account linking. So when they are enabling the skill, it asks you to log into your banking platform. So it's possible to enable account linking for any platform that you kind of can authenticate your user. So that way you know that person is the person that wants to interact with, and just enable it. At the same time, there might be some other households, so you can get creative and just at the point that they want to interact, just send SMS to their mobile so that they can just verify and say those type of things. There are things in place to help you in that sense. Yeah. Okay, thank you everyone. I'm available today and tomorrow. If you have any questions for Alexa, please let me know. Thank you.
Hey everybody, I'm Ben. When we were checking the screen before, I'm doing a little bit of live coding in this presentation, and we noticed that the colours are a bit wonky. So if you want to come up a bit closer to see things, now's the time to do it. At the very least, you'll have a front row seat if this live coding comes off the rails. Who here has worked with GraphQL? Anyone work with GraphQL in this room? Who knows what GraphQL is? Okay, all right, good. So I work for a consultancy called Shine Solutions, and we build a lot of big clients for people, and we think that, I'm ready to switch the, thank you. We think that GraphQL is a pretty compelling alternative if you want to, if you've got really complex clients, basically. And so there are lots of client-side libraries out there for interacting with GraphQL servers, but actually writing your own GraphQL server is something that's not really covered as much, and I think it's really worth understanding a little bit. So why would you write your own GraphQL server? Because there are hosted offerings out there. There's things like GraphQL, Prisma, even Amazon have AppSync. But if you work for the sorts of people that we do, like big enterprises and stuff like that, they don't really want to use a third-party service to do that sort of thing. If they're going to use GraphQL at all, they'll be writing their own server. So I'm just going to try and give you a feel for how easy it is to write your own server, or at least get started. We're going to use the old Chestnut, a to-do app for this, because we haven't got much time. This is yet another to-do app that I wrote, but it's got a little bit of a twist because not only can you add to-dos to the list, but for each to-do you can add subtasks. Okay, and I've sort of made this little extension because it means that this app actually has a schema. Specifically, a to-do can have many subtasks. And being a GraphQL app, we can actually represent this schema using a GraphQL schema. So we've got a couple of types to find here. We have a to-do, and it's got 3 fields on it, an ID, a description, and an array of subtasks. We have a type for a subtask that's got 2 fields on it, an ID and a description. All the exclamation marks just mean that things are nullable. The schema also contains types for a type for a query, for what's called a query type. Now, this is sort of a special type in some senses, but it's just like other types in other senses. So fields can actually have arguments passed to them. So to-dos is just a regular field. This is a query that will get all of the to-dos for an app, but we also are wanting to get an individual to-do, and so that field actually has an ID that can be passed to it. But in every other sense, a query is just another type. However, when a request comes in that is prefixed with this query operation at the start, the GraphQL server will know that it's got to look at the query type. This is kind of for the root level queries, basically. And here's another example where an argument is passed into a query. All right, mutations are a little bit more complicated. They are also queries, but they have side effects. So we tend to use more of an imperative naming for those. So here's some mutation kind of fields, I guess you'd still call them, in a mutation type. And this is so that you can run a query like this. So when it sees the mutation operation down in the query, then it'll know that it's got to look at the mutation type. So in that sense, mutation and query with a capital Q and a capital M are a sort of a special sort of type, but otherwise they're just like any other. All right, so because we've got limited time, I've already set up a database. This is just like some JavaScript, some Node JavaScript that uses a SQLize library, it's like an OR mapper. Just gives me an easy way to manipulate these entities in the SQLite database. First step is we're going to use Apollo server to do this. So this is just something you would have with Yarn or NPM. And we're also bringing in Facebook's GraphQL module, although that's really just a peer dependency of Apollo server. So let's now pray to the coding gods and try and get this together. So we've got the app here on the right. There's nothing really running at the moment. So if I run the app, it's going to just die nastily. So here on the left, I've sort of got the start of a server.js file. At the top, we're bringing in a couple of objects from the Node modules. Then I've just got a little bit of housekeeping here to load the schema file into memory. I'll talk about resolvers in a second. And I'm also going to take this schema string, because it really is just a string at this point, and convert it into a proper object. So to actually write a server, we're going to create a new Apollo server. And at Apollo server, you have 2 important things you have to provide to it. You need to provide this object that describes your schema, basically, plus you need to provide these resolvers. And don't worry, I'll get to the resolvers in a second. To actually start the server, I'm just going to go here, and we'll just that's everything. All right, and we'll crank our server up here. I'm going to use, this is basically just a node process. I'm running it using NodeMon, so it'll just pick up changes as we go. So resolvers. a really important concept when you're writing a server. Resolver maps a type and even a field to a function. It actually fetches the data for that field. So our server is running here, but it's still going to kind of die because we need to get a resolver in place. So we'll open up the resolvers file, and it's really just a map. Okay. At the top level, we've got a empty object for the query type, and we're going to add one for to-do. So this will be a function. Return to-do dot find all. So we do that, our server starts again, and there are our to-dos fetched out of our database. But there's another query that we want to do. We want to be able to click through to a to-do item, and the server doesn't support that at the moment. Let's have a look at the, let's have a look at the query. This is a little bit more of a complex query in that it's taking an argument, and it also asks for subtasks. Each resolver gets a couple of parameters passed to it. The first one is kind of the root object or the parent object that it's working from. In the case of a query, the parent object doesn't really, in this context, isn't really relevant. It's just kind of a root object. The second argument is the stuff that was passed to the field. Put that there. Now, it can be tempting at this point to just try it and see if it's going to work, but there's one more thing we've got to do, and that is that we've got these subtasks that are being requested. Not only are we asking for the to-do object, but we're asking for its subtasks. And, you know, at the moment, these resolvers don't know anything about that. But this is kind of where we can work into the kind of magic of GraphQL a little bit more, and we can provide a resolvers for the to-do task here, specifically on the subtasks field of to-do, which is being requested. We can say, we can provide a resolver, and in this case the parent object is relevant because the parent object is the to-do that's been looked up previously. So we'll go to-do dot subtasks. There we go. There you go. So we've just loaded the to-do and we've loaded all of its subtasks. Yep.
So Apache composed those two on the server side and brought that one.
Apollo. Yes, absolutely. So yeah, so the client passed this query through, and the Apollo server first got the to-do, so it ran the to-do resolver, and then the server said, "Oh, look, I've got this object of this field of type to-do, and they've asked for subtasks, so I'm going to go and recursively go through and get the subtasks for it as well." And that's kind of, in my opinion, sort of the magic of GraphQL and writing a server. We'll do just one more thing. We'll do the no, not here. We'll do creation. So we've got, now similarly we had a mutation type that we defined before. To do will be, don't care about the parent as much in this case. Actually, we're just going to take the description right out of it. So if I try and create a to do at the moment, not much is going to happen because there's nothing there. Now, mutations are still queries, so they can return data. When you run them, you can say, I want this stuff back, but they have this kind of side effect. So we are going to return something, but most importantly, we're going to actually create the to-do just here. And there you go. There's the thing coming in. All right, so a few kind of things I just want to make clear in case there hasn't quite dropped here. So we ran a really simple to-dos query that looked like this, and what actually happened under the hood is that the server returned something like this to the client, sort of an array of objects. The cool thing about what I've done is that say that when I get all to-dos, I also wanted to get all the tasks, all the subtasks for each to-do, all in the list, all in one hit. So say that I wanted to run a query like this, okay? The client isn't really doing it at the moment, but say that I wanted to do this. The server basically out of the box would just automatically do it all for me. Okay, I wouldn't need to add any extra code to support this getting this extra data. Which is one of the things, which is why we think GraphQL is really good for complex clients where you can't be sure up front exactly what data the client's going to need. So a few important things just to sort of close out. I've used a database for this, but this really isn't for just being a really dumb front end on a database. GraphQL servers can be really powerful when you're aggregating data from different sources, especially like REST APIs and things like that. and you want to sort of combine them all together into one unified schema. Secondly, security. Now, in the real world, you probably actually don't want to allow clients to be able to run any query they want against your GraphQL server. If anything, just because you get like a denial of service style attacks where people could just send massive nested queries to you. So there's a couple of strategies you can use to deal with that. You can whitelist queries is probably the most hardcore one that you can do. So during development, sure, devs can run whatever queries they want, but before it goes into a prod environment, you actually constrain the queries that are coming in. Usually just associate an ID with them. And in doing that, you can also deal with performance. So when you start to say only these queries are permitted, you can really just have like a hash associated with them. You also have maybe take the data that is supplied to that query, and all of a sudden you've got like a cache key that you can use, even with a big CDN or something like that. So despite it not maybe looking like it at first, you can actually use traditional caching servers like, say, Akamai or whatever, services like Akamai with a Apollo or a GraphQL server. And finally, you don't have to do this with Node. You don't have to write a server with Node. There's frameworks for other languages like Java and Ruby, if that's your kind of preferred option. But I think the most important thing for you to go away with anything from this presentation is that when you use GraphQL, you really think in terms of the schema and the endpoints. If you get the schema right, and then you implement a set of resolvers that can satisfy or work with that schema, then you don't need to worry about having different custom endpoints anymore. Once you've got it in place, it can pretty much give your clients all that they need. Thanks very much. Any questions? You got all the information that you needed from that presentation? All right, thanks very much, guys. Cheers.
Hello and welcome to building single-page applications with ASP.NET Core 2.2. Originally I was going to do this presentation on 2.1, but we know that that's legacy source code, and I'm not going to do that to you guys. So I bring you the Extreme Edition, ASP.NET Core 2.2 support, Preview 2, which was released just 1 week ago. Let's get started. So my name's Jason Taylor. I'm an SSW solution architect. And if you know me, if you've heard me talk before, you know that I value one thing, and that's keeping it simple. So today, I'm going to show you the simplest approach to single-page application development with ASP.NET Core 2.2. Let's start with the prerequisites. They are very simple. If you want to develop with .NET Core 2.2, you need to install .NET Core 2.2. Now, if you want to develop with single-page applications, you need to install Node, so version 6 or later. With that in place, we have 3 choices. Out of the box, we can create an Angular application, a React application, or a React and Redux application. You can also develop with your own framework, of course. There's just not an out-of-the-box template. So let's try it out. So to create any one of those applications, all we have to do is type .NET New. Now we can type Angular, React, or React and Redux. I'll just increase that font size a little bit. Oh, actually, I'll zoom in. So you can see that it's created the application, and it's also restored all of the NuGet dependencies. So we can jump in. I'll type code dot to load it in Visual Studio Code. And we can see the solution structure. So it's essentially an ASP.NET Core MVC application with an Angular application built in. So because I've chosen Angular, it's using the Angular CLI, and you can find that in the client app folder. If I was using React, it would use the React Create App CLI. So we're using Angular 6 in this case with Bootstrap 4, and the React one would be React version 15. So if I dive into the client app, you can see it looks very much like a typical Angular CLI application. In fact, they're really loosely coupled. I can delete that and go ng new, and it's still all going to work. On top of that, I have everything that you'd expect in the ASP.NET Core application, but I can build and deploy them as a single unit, so that makes life a lot easier. Now I could start that application, but then it would restore the npm dependencies, and that takes forever. So we'll go to this one that I've already created. Now to run this, all I have to do is type .NET run. So I can do that from the VS Code terminal, and it'll kick it off. So it does basically three things. It's going to build the application, it's going to launch the backend, so Kestrel, and it's going to launch the front end, so the Angular CLI server. That does take a little bit of time to launch, about 10 seconds, and that can be problematic. So I'm going to show you in the next section a way that we can avoid that. But you can see that it's launched. Now if I control click on that, it'll actually go to the application. And we're still waiting for Angular CLI to start. It's kicking off there now. So that takes a little bit, but over here, you can see that it comes with 3 pages. So all of these templates have these 3 pages to help you get started. So the first page is a description of the front end and back end technologies, along with the features that are included in the template. The second page is a simple counter component, and the third page is a little bit more advanced fetch data component. So that fetches data from the ASP.NET Core backend controller and renders it on the front page. So you can see that's kicked off now, and it's up and running, but I'll stop that. So very easy to get started. Just run .NET New Angular, React, or React Redux. So let's have a look at how we can improve our productivity when we're developing with these templates. So the first thing that I kind of hinted at was that it can take a long time to start the application. Now if we jump into startup.cs, right down the bottom here, you can see that in a development environment, we'll get rid of that, should have enough space, there we go. It says use Angular CLI. If it was React, it'd be saying use React. And it just starts an npm script. So we can just comment that out. We don't want it to start automatically. And we can tell it to just use the proxy to the development server. And that means that they're going to start independently now. And that's really great, because when we make backend changes, if we're starting them together, that means we have to kill the server, which will also kill the front end server, which means it's going to be another at least 10 seconds before we can start it up all again. So by separating them out, we avoid that problem. Now I could go ahead and launch this in VS Code again, but that's problematic too. If you use VS Code, you know that from time to time you need to reload it, and that's going to cause your servers to reload as well. So we can avoid that problem just by using separate terminals or command prompts. So now I need to start the front end, and I can just run that same script, npm start from the client app directory, and I need to start the back end. Ideally, the front end should be started and up and running before you start the back end, and I can type .NET run. So if I do that, that's all going to be up and running. But then we have one other problem that I'd like to solve. If I make a change to the backend file, I'm still going to have to stop Kestrel and restart it again, the web server that runs our backend. I can avoid that by using a tool called .NET Watch. So .NET Watch basically will monitor our backend files, and if there's a change, it's going to automatically rebuild and relaunch. So we can do that using .NET Watch run, just like that. So instead of using .NET Run, we use .NET Watch Run, and now our backend will monitor our files for changes, automatically restart, and our front end will do the same thing. So we only focus on one thing after that, just writing code. We can change the front end, we can change the back end, all that stuff happens without our interaction. And if Visual Studio Code does need to be reloaded, as it often does, it's not going to impact any of that. So we avoid all of those issues. So the next thing I want to show you is how to take your development to the next level of single page application development. First, let's have a look at the fetch data sample. So with the fetch data sample, we have the fetch data component sitting on the front end and the sample data controller sitting on the back end. From the component, we make a request for some weather forecasts. And then from the sample data controller, we return the response, which is a weather forecast array. So that's really simple, right? But it's a little bit problematic. Let's take a look at the source code. So the source code actually uses the Angular HTTP client to make that GET request. We have to specify the URL. We need to know what the URL is, and then we map the result to a local collection. We also have to recreate the type on the front end. So we've got the weather forecast type on the back end, and we've got it on the front end as well. So the problem is that it requires knowledge of the API. The developers need to actually look at the source code to understand what endpoints they can hit, what results are going to be returned, what the shape of those results are. We've got hard-coded URLs, we've got duplication of backend types, and breaking changes are hard to detect. If we change the backend, yeah, sure, it's going to automatically rebuild, and that's fantastic, but Angular's not going to know that something's broken. It's not going to know that the name of that endpoint has changed. So let's have a look at how we can solve that with OpenAPI. So as you know, OpenAPI, or Swagger, is an API description language. It describes REST APIs. So when I develop with OpenAPI, I like to use a tool called NSwag. And we won't spend too much time in this, but suffice to say that I use this tool to build a configuration, an NSwag configuration. And using that configuration, I can do two things. I can generate the actual Swagger specification. As you can see there, it describes my API. And I can also generate a TypeScript client. And I can generate this for Angular or for React. But then instead of writing this code by hand, I can use that TypeScript client. So I've done that. And inside my application, I have an nswag.json, which is the configuration file. I'll just scroll up, try to scroll up, there we go. So it does the API specification and the TypeScript client, and I have the API specification has been generated and is part of the project, and I have the generated TypeScript client. Now I can do quite a lot with that. In startup.cs, I've installed a package called nswag ASP.NET Core, and if I scroll down a little bit, I'm telling it to use Swagger UI. So on the interface, on the website, I can type /docs, and my developers that I'm working with can go here and learn all about the API. So they don't need to just look through code. They can come here and actually try it out for themselves. So I go try it out and execute. I can get the weather forecast even before I write any UI. Down the bottom, I can also see all the types associated with this API, so the view models, the DTOs, that sort of thing. So we can learn a lot as a developer just by looking at that. But the fun part is that I've generated this TypeScript client, and now we can go and refactor that fetch data component and try and remove some of those issues. Now also remember, in the back end, I've still got both of those processes running. So this is a little bit of live coding. So we can clean this up quite a bit. Let me make this a touch bigger. There we go. So I'm not going to need to inject anything, well not at least not in that sense. I don't need the HTTP client anymore. I don't need most of this constructor. I don't need any of this. I don't need this duplicated type, which was violating dry. Really, all I need to do is bring in the weather forecast type, which is being generated for me now based on the backend type, and bring in the sample data client. And with that, it's really easy. I can just make my request. So I go client.weatherforecast.subscribe. We get the result. We map it to the forecasts. We get an error if there's an error. And we can console.error that out. And that's it. So with that running, Angular's picked that up, and if we go back to the home, I will go over to this one. If we go here, fetch data, it's working exactly the same, but it's a lot simpler. And if I look at those changes, you can see, even for this component, we've taken a lot out, we've simplified it in many ways, and that's just one component for what is currently a trivial application. Think about on the scale of a medium or large application for your enterprise. It makes a massive difference. Okay, so I promised that breaking changes would be easy to detect. So let's just see that in action. I'll make sure these windows are ready, and we'll go to our controller. Oh, not that one. I'm just going to change the name of the action. That's a simple breaking change. ABC. I minimize that. So the backend's detected that change, rebuilt and reserved. Now what's going to happen is using MS Build, NSWAG is going to generate a new API specification and a new TypeScript client. Now Angular is going to detect those changes and actually say, hey, we've got breaking changes. So you can see there it's come up and says weather forecast doesn't exist. And all I did was change the controller and save the changes. All of that's happening automatically. Visual Studio Code is probably going to complain about the changes pretty quickly too. But let's fix it, save those changes, and it should be right. Sometimes Visual Studio Code takes a little bit longer to catch up, but you can see Angular's compiled successfully, and it's back up and running with weather forecasts ABC. So let's take a look at this one last time. Now we just inject weather forecast and the sample data client, and we make a simple request, and we fixed all the issues. We can explore API endpoints either through Swagger UI or the generated client. There's no hard-coded URLs, there's no duplication of backend types, and breaking changes are easy to detect. So next steps, if you liked what you saw today, take a moment to look at the companion guide and resources. So everything that I've shown here, including some stuff that I didn't show, such as creating the NSWAG configuration for the specification and the client, you can find in this blog post. So it's covered in great detail. I'll show you quickly. So yeah, just come to my blog. It's the very first post there. And it's a big post. It took me quite a while to write. So yeah, it covers everything that we talked about today, plus all of the open API. So it'll teach you how to do that in detail, including integrate it with MS Build so that you get that real magic happening behind the scenes. So feel free to look at the posts, ask some questions. I'll definitely be monitoring that, or come and see me over the next couple of days and we can talk. Thank you.